We liked integration by parts so much, we're going to do it again. Why not? Now, when you're looking at the problem, so you can see that you have two functions that are multiplied. You have a t and you have an e to the t dt. Now remember, Lipit, right? L-I-P-E-T. Logarithms, inverse trig, polynomials, exponentials, trig. So when I look at these two, I have a function right here at the front, which is t, and I have an e to the t. And so what I want to do is I want to make a table, and I want one of those functions to be u. Well, again, Lipit for u, so I don't have a logarithm, I don't have an inverse trig, but I do have a polynomial. My polynomial is t. So let's find the derivative right now. Right? I found u, so let's find du. The derivative of t with respect to with respect to t is 1 dt. Okay? Then that means that the rest of this has to be dv. So dv is e to the t dt. And then v is the integral of that, because that's the derivative of something. So you have to find what the integral is, right? The antiderivative. And the antiderivative e to the t is e to the t. Love that one. Everybody's favorite. All right, so now when we do integration by parts, we say, hey, this is u and this is dv. And the integral of u dv is u v minus integral v du. That's integration by parts. It's not equal really, because of course it's kind of switched over, but this will be the equal part. All right, so u is t. V, that's e to the t minus integral v, which is e to the t again, du, which is just 1 dt. And of course you don't really have to write the 1. There's nothing there. Okay, so then this is t e to the t. That part hasn't changed. There's no integral left on that, so there's nothing left to do. We've done that part. Minus, and then we need the integral of e to the t dt. But the integral of e to the t is e to the t. So this is just e to the t plus c. And we're done. Okay, so that was easy. All right, now we know how to do a basic integration by parts. How can we kick it up a notch and make it more difficult? And the answer is, well, we can make you do it more than once. So let's see how this goes. So we are going to repeat integration by parts. We're going to do it multiple times in the same problem. And this will happen. Sometimes it's just necessary. You'll see. It'll break down. Okay, so this is very similar to the problem we just did. Hopefully you can see there's your u, there's your dv. Now, why do I say that's u? Well, because when I do this, I want my u to be the polynomial. So then du is 2t dt. And yes, you do write all of this down, and it has to be in this little table and everything. dv is right there. It's e to the negative t dt. So then v is the integral of that, the antiderivative. The antiderivative of e to the something is e to the something. However, because it's not just t, it's negative t, I'm going to need a negative out in front. It's basically the reverse of the chain rule. Now, double check yourself. You should be able to take the derivative of v and get dv. So if you took the derivative of e to the negative t, it'd be e to the negative t times a negative 1. So since there's a negative already here, the negative 1 and the negative will cancel and become positive. So this will work. Okay, so now let's rewrite this. One more time. It's u v minus integral v du. Du. I have too many peaks there in my u. All right, so u was t squared. V is negative e to the negative t. I'm kind of cutting quarters by putting the negative out in front there. Minus integral v So that'll be a negative e to the negative t du, which is a 2t dt. You know what? I guess I'm not going to cut corners. I'm going to put that negative right there with that e to the negative t, just so you really can see it. So this is t squared, and this is a negative, like that. Okay, now let's clean this up because this is a mess. All right, so this part in the beginning is no problem. So this is t squared and a negative, so it'll be negative t squared e to the negative t, which is what I wrote earlier, so that's fine. This is a minus 2, so this is plus 2 integral of t, because I've got a t left in there, and then an e to the negative t dt. I've already taken care of the negative and the 2 by putting them up here, right? Negative makes positive, and then the 2. But look there. You see what I mean? We're going to need another application of this. So we have one table, and now we need another one. So here was the first application of the integration by parts rule. And now what we're going to do is do it again. Here's u. Here's dv. See it? Right? It's very similar to the previous example. That's one of the reasons I didn't mind this example kind of coming over into the next one. Okay, so for this next one, u is t, du is the derivative of that, which is 1 dt, dv. So if you like, you could call this u1, and then this is now u2, right? Because you're doing it again, just if you want to keep it a little bit more straight in your head. So dv is the e to the negative t dt again, which again, just like it was before, is negative e to the negative t, right? You take the integral of that. Okay, so I still have my negative t squared e to the negative t. Like, this part hasn't changed, so that's fine. Plus 2. And then now what's going to happen in here is I'm going to get another u v minus integral v du going on in here. Right? I'm going to do another integration by parts. So I had one of them up here. So if you like, this is u1. Give me 1 second here. So this was u number 1, v number 1 minus integral, and then v1 du 1. Right, that's what we did. So now I'm going to do it again. So this is u number 2, du number 2, v number 2, and v number 2. There you go. So those are 2's. It looks a little weird there. That's a 2. Okay, so u2 would be t. v2 is negative e to the negative t, and those are multiplied. So it's u times v minus integral v, which is negative e to the negative t, du, which is now 1 dt. Or just dt if you like. There's my second application of integration by parts. All right, so this is, again, negative t squared e to the negative t. Nothing's happened there. Plus 2. Now this is going to be negative t e to the negative t minus a minus. Now look there. There's 2 negatives. So that's plus integral of e to the negative t. And then a dt. I'm just distributing the 2. You can do it later, you can do it now, one way or another. You're going to have to send the 2 in. I mean, you don't have to, but why wouldn't you, right? Okay, so then the integral of e to the negative t we've already done. Yeah, you could have waited on distributing the 2. It didn't have to be done right away. Technically, it doesn't have to ever be done, but I wanted to do it. All right, I'm erasing my plus sign because it won't be a plus. When I integrate e to the negative t, it's going to be yet again negative e to the negative t. And then the 2 is just sitting there. And finally, I get to put my constant of integration and say plus c because I'm finally done with the problem. Now, if you want to, I noticed personally that there's a negative and an e to the negative t in every single one of these terms. So we also could write it as negative e to the negative t times t squared plus 2t, because we're factoring out the negative, plus 2. That would also work and be correct. So that's what it looks like to do a repeated integration by parts. Right? Not super difficult, but you just have to keep track and be very careful with what you're doing. Right? So 2 was times this whole thing, and then you eventually distribute it or factor it or whatever. Right? So we try to keep it very clear and clean. We have one application up here, and then we have a second application nested inside that first application. That's why it's 2 times all of that. So being clean with your notation will be very important for these problems.